Hello students, today we are going to study about entropy. Now this entropy is represented as S. Now what do you mean by entropy? We can say that entropy means it is the randomness of a system. Now what does this mean, randomness? It means the freedom of a system. How much a system is free. The randomness or the entropy can be also defined as the disorderness of a system. Now this entropy is a thermodynamic property. Now when we are saying the entropy is a thermodynamic property, that means it depends upon what? It depends upon the pressure, temperature, internal energy, etc. So since it is a thermodynamic property, it depends upon these factors. Now in the case of entropy, we said that we are representing entropy as S. Now the absolute entropy of a system cannot be calculated. It is difficult to calculate the absolute entropy of a system. So how can we calculate the entropy? Absolute entropy cannot be calculated, but the change in entropy can be calculated. The change in entropy is given as S final minus S initial, or it can be represented as what? S2 minus S1. Now since the change in entropy depends upon the final and the initial state, we can say that what it is a what function? It is a state function. We have already discussed what do you mean by state function and path function. So, the change in entropy can be represented as final entropy minus initial entropy, and we can say that what entropy is a state function. Now, in the case of entropy, the thermodynamic change in entropy can be represented by the formula delta S equal to Q reversible by T. This formula is important. Based on this formula, problems are asked. What is that? Delta S equal to Q reversible by T. Now, what does this Q reversible means? This Q reversible represents the what? It represents the heat exchange for which type of reaction? The reactions which are reversible in nature. And what does this T means? The T represent? We all know. What is T? T is the temperature. So based on this formula, we can find out what is the unit for this change in entropy. What is that? The Q is represented in terms of joules, or what? In terms of calorie. And temperature is represented in terms of Kelvin. So it will be, the unit will be what? It will be joule by Kelvin, Q by T. So it will be joule Kelvin inverse, or instead of joule, we can also write it what? We can also write it as calorie. So it will be calorie by Kelvin or calorie Kelvin inverse. Now one thing that you have to remember is this Q reversible is a state function. Now why we are saying Q is a path function, but why we are saying Q reversible is a state function? Because it takes place, or only one type of path is followed. So Q reversible is a state function. We have already said S means what? It is the randomness of a system. So if we are considering our phases, solid, liquid and gas, you can say that the randomness or freedom is most greater, or randomness or freedom is greater in the case of what? The greater in the case of gaseous molecules. So out of these three phases, the entropy will be maximum for which phase? It will be maximum for the gaseous phase. Now as discussed, we have discussed entropy and the change in entropy. The one point that you have to remember is that what happens? Entropy is directly proportional to temperature. So as temperature increases, what happens? Entropy also increases. This is an important point that you should remember. As temperature increases, entropy also increases. But what about the change in entropy? From this formula, you can see that the change in entropy is inversely proportional to what? Temperature. So, if our temperature is low, what happens? The change in entropy will be higher, and vice versa. That is, if temperature is high, the change in entropy will be what? The change in entropy will be lower. Now let us consider spontaneity, or let us consider the spontaneous process and how does it affect the entropy of a system. Now what do you mean by spontaneous process? The process which happens by itself. Okay. When we are saying spontaneous process, we can say that the process which occurs by itself are known as spontaneous process, or they require very small amount of little push or very small amount of energy. Whereas when we are talking about non-spontaneous process, what are non-spontaneous process? The opposite of this one, that is the process which cannot take place on their own, or the reactions which cannot take place of their own are known as what? Our cannot take place on their own. They need a small amount of energy, or their push is known as what? Non-spontaneous process. Now the point that we have to remember is that the change in entropy will be positive for a spontaneous process. So when we are saying the spontaneous process, the change in entropy should be always positive for a spontaneous process, whereas in the case of a non-spontaneous process, the change in entropy is always negative. So for a non-spontaneous process, the value of delta S will be less than 0. Now our third case, we are talking about spontaneous process, non-spontaneous process. What is the change in the entropy in the case of a reversible process? Now let us consider, in the case of a reversible process, you have to remember the change in entropy is always represented as 0, or the change in entropy in the case of a reversible process is 0. Now, if we consider a reversible process, let us consider we are considering an isothermal process. So, when we are saying isothermal process means what? The temperature remains constant. So, here we are taking a system, and here what is that? Outside the system, our surrounding is there. So, when a small amount of heat is transferred to the surrounding, or a small amount of temperature change occurs, it is so small that what is that? There is particularly no change in the temperature of the surrounding. So, we can represent it as what? Delta S system equal to minus dq by t, based on our formula. Why we are writing minus dq? Because the system has lost its heat to the surrounding. And why we are writing it as d? Because a very small, a negligible amount of heat is transferred. And what about our surrounding? Even though it is negligible amount, the system has gained very little amount of heat from the surrounding. So when here you can see that the delta S system will be minus dq by t, and delta S surrounding will be what? Plus dq by t. Now what is the total change in the entropy? The total change in the entropy is the, what is that? The change of the surrounding and change of the system, that is minus dq by t plus dq by t. So delta S becomes what? 0. So for an isothermal process, what happens? The change in entropy is represented by the term, what is that? It is 0. Now if we consider an adiabatic process, what does this adiabatic process means? We have already discussed. In the case of adiabatic process, there will be no heat exchange. No exchange of heat is taking place. So since no exchange of heat is taking place between the system and the surrounding, what will happen? The change in the surrounding and the change in entropy of the surrounding and the system will be what? It will be equal to 0. Now if we consider an irreversible process, let us consider an irreversible process. So in this case we can see that, let us see here, what is that? The system is transferring its heats to the surrounding. That means the system is at an higher, since it is an irreversible process, the system is transferring its heat to the surrounding. Now when can the system transfer its heats to the surrounding? When it is present at what? The system is having a higher temperature and the surrounding is having a lower temperature. So we can represent it like this. The change in entropy of the system is minus dq by T1, because T1 is, the temperature is a higher one, and delta is surrounding it. It is accepting that, or it is gaining that heat. So it is dq by T. So delta S total is S1 plus S2, which can be represented as delta S system plus delta S surrounding. So we have arrived minus dq by T1 plus dq by T2 is dq 1 by T2 minus T1, or dq is equal to T1 minus T2. Now here T1 is at a higher temperature. So it will be what? It will be greater than 0. So for an irreversible process, what we can say? For an irreversible process, the delta S total is what? The delta S total is greater than 0, or we can say that the delta S, the change in entropy for a universe is greater than or equal to 0. Why it is greater than? Because for an irreversible process, the change in entropy, the total change in entropy is greater than 0. Whereas for a reversible process, it is what? It is equal to 0. So, delta S universe is greater than equal to 0. Now, in this module or in this video, what are the important points that you should remember in the case of entropy? Here we have learned. So, the points to remember is that the first point that we should remember is that the entropy is what? Entropy is a state function. The formula, the change in entropy is thermodynamic changes in entropy is represented by Q reversible by T. The delta S value is greater than 0 or it is positive for which type of reaction? For spontaneous process, the delta S value will be positive, and for non-spontaneous process, the value for delta will be what? The delta will be negative. Again, the total entropy change is 0 in the case of an reversible process, and it is greater than 0 in the case of an irreversible process. So, delta S universe is what? It is greater than equal to 0. Why it is greater than equal to 0? Because for the reversible process, it is equal to 0, and for an irreversible process, what is that? It is equal to 0. For irreversible process, greater than 0, and for a reversible process, it is equal to 0. Hope these much things are clear. Thank you.